You know that feeling when you ask a search engine a really specific question and it just throws a bunch of links at you? It's like it's not even listening, just guessing. You're left to piece it all together yourself. Well, the entire world of AI is trying to make a huge leap to go from just searching for keywords to actually understanding what you mean. Okay, take a question like this one. A normal search engine would pretty much choke on it, right? It'll find a list of Olympic cities, sure, and a list of big European cities, maybe even a map of the coast. It gives you all the ingredients, but you're the one who has to do all the cooking. The problem is, this question takes logic, not just keyword matching. And this is where you can really see the difference. On the left, that's what we're all used to, that mess of blue links where all the work is still on you. But on the right, that's the goal. That's intelligent question answering, a single, direct, and correct answer. The machine didn't just find stuff, it actually processed it. So how do we get there? How do we make that jump? Well, it's not about cramming more websites or more data into the AI. The real secret, the game changer, is teaching it how to reason. It's about teaching the machine how to think, not just how to fetch. And that brings us to our first big idea. How in the world do you get a machine to understand our messy, kind of weird human language in a way it can actually use? Well, it all starts by translating our words into its native tongue, the language of pure logic. The technical term for this is semantic translation, and it's an absolutely crucial first step. It's where all the ambiguity of how we talk gets stripped away, and the sentence gets rebuilt as a precise mathematical formula that a computer can actually solve. It's kind of like turning a poem into an equation. This flowchart just lays out the AI's whole thought process perfectly. It takes our question, does that semantic translation into a formal logic version, and then, and this is the magic part, it performs what's called logical inference to come up with an answer that might not have been written down anywhere before. And you gotta love that phrase, derive logical consequences. That's the heart of it all. This isn't just about finding a fact that already exists. It's about taking a bunch of facts you already know and creating a brand new one. That's the difference between a dictionary and a detective. But, just understanding the words is only half the battle. The AI also has to figure out the intent of the question. Like, what kind of answer are we actually looking for? What's the game plan to get there? So how does an AI even begin to tackle that? Well, to do this, researchers have some really cool tools. One is called inquisitive semantics, and it helps the AI understand the goal of the question, what information is actually being requested. Then there's inferential erotetic logic, which helps the AI create a strategy, breaking that big question down into smaller, solvable pieces. And that whole process of breaking down the question, it's called creating an erotetic search scenario. Just think of it like the AI writing a to-do list for itself. For that Olympics question, the list would be 1. Find all European cities with over 1 million people. 2. Check which of those hosted the Olympics. 3. Cross out any that are on the coast. It's a logical roadmap to get to the answer. Okay, so the AI can translate our words, and it can figure out our goals. But our language is still just incredibly messy, isn't it? It's packed with context and vagueness and all sorts of hidden meanings. And this is where things get really tricky. I mean, just look at these hurdles. The meaning of a sentence can flip completely depending on the context. Words like many or few or most, how do you quantify that? We use vague ideas all the time, and even simple sentences can have these deep, hidden logical structures. It's a minefield for a computer. No, seriously, think about it for a second. How is a machine that's built on absolute ones and zeros supposed to handle a concept like tall? A tall person is totally different from a tall building. Or what about the word many? 10 people is many for a car, for sure. But for a city? Not at all. That kind of thinking just completely breaks a computer's rigid black and white brain. So the solution is to let the AI get a little, well, fuzzy. Fuzzy natural logic is this amazing system that lets an AI move beyond that binary true or false world. It lets the machine work in shades of gray, assigning a degree of truth to something, and that is so much closer to how we humans actually think. This table just makes the difference so clear. Classic old-school logic is totally binary. Something is either 100% true or 100% false, period. But with fuzzy logic, truth can be a value between 0 and 1. So a person isn't just tall or not tall, they might be, say, 0.8 tall. It's that flexibility that finally lets an AI start to understand the nuanced way we actually talk.
So you've got these incredible tools, right? Semantic translation to get the words, question logic to get the goals, and fuzzy logic to handle all the messiness. The future, the big goal here, is to weave all of these together into one single smart system.
And that's exactly what's happening right now. These cutting-edge frameworks you see, things like natural logic and discourse representation theory, they're being built to do just that. They're trying to build systems that can follow a conversation, that can understand context over multiple sentences, and can reason with our language in a much more complete, human-like way.
So here's the bottom line. The whole journey from a simple search box to an AI you can actually talk to, it's all paved with logic. By teaching machines the deep, intricate structure of our language, we're finally pulling them away from being simple keyword finders and pushing them towards becoming real, genuine reasoning engines. And that kind of leaves us with one last wild thought. As we get better and better at teaching AI the logic of how we speak, we're basically creating this perfect mirror of our own minds. And if that AI can actually master our logic, what hidden patterns, what unspoken rules might it show us about the very way we think?